So in today's video, what we are going to do, we are going to discuss various technique to efficiently detect the intent of from the user query. Let me just run this code. If you see, it has detected something like intent is product inquiry, product name is iPhone 16, confidence is 0.95, but a large number of documents it can tag using this OpenAI metadata tagger feature. Hey everyone, welcome back to the channel. So in our previous video we discussed about LLM agents in brief, and we saw the four basic components that are that makes up agent, right? So the first component, we saw that the first component is to detect the intent of the user query. That means to identify what the user is trying to ask and what path should we follow, to answer the particular user's query. Then the planning and reasoning step, then the tool usage and output generation steps come into picture. So the first and basic foremost step is to detect the intent. So in today's video, what we are going to do, we are going to discuss various techniques to efficiently detect the intent of from the user query and generate and extract metadata information, so that we can use those information later in the planning and reasoning step, and then in the tool usage also. Okay, so let's just directly jump into the code. So in the first example, what we are going to do, we are going to implement intent detection using just the OpenAI ChatGPT model. Okay, we'll use the OpenAI LLM to detect the intent from a given user query, and we'll be using basic prompting techniques to get it done. So let's just go through the code once. So here I have imported some packages and I have imported my OpenAI key also. Let me just import that, and then I've created a class called LLM agent. Okay, and here obviously we have the constructor here, and then we have a method called query LLM, which does nothing but it just takes the prompt as an input. It will just use the prompt and send it to the OpenAI chat model, and generate a response for it, right? So this is pretty simple. Now the main thing is the detect intent function here that you can see. Now if you can see, it takes the query as the parameter, the user query that the user is typing, and then we are preparing a very detailed prompt like this. If you see, we have created prompt like, you are an intent detection system, identify the intent of the user query from these categories. The intents can be check order status. Let's assume we are developing e-commerce application where we want to integrate LLM, right? LLM based chatbot into our application, so that users can do stuffs in the chatbot itself without doing things manual, like canceling order, product inquiry. All those things can be done on a chatbot, let's say, right? So there can be multiple intents like this. I have taken 4-5 of them. The first is, let's say, check order status, then cancel order, product inquiry to get the information about a particular product, technical support for chatting with the customer support and debugging your issue that you're facing. And if any of the if the query does not fall into any of these categories, we'll use the other technique. Okay, then using this prompt, if you can see, we have placed a query here also, and then finally we are passing this prompt to our query LLM function. So basically this entire big prompt will be passed to the OpenAI model, which will generate a response for us. So it's quite simple. We just have LLM model in place. We are just preparing a prompt to detect the intent based on the use cases of your application. This prompts will vary, right? Let's say you are building something for analyzing financial stocks, right? So the prompts can vary in this, right? The prompt content, the intents can vary, so you can manually mention intents like this. Now let's just run this code once. It will see how does it how is it able to get the intent. So if you see, I've written some query. I want to cancel my order. Let's run this code. If you see, it efficiently detected the intent for this. Then let's just run this. Can you share specs of new iPhone 16? It's a product inquiry thing, right? So we are basically inquiring about a product. Now the next query is to my display is not working, how to fix it. So it's a technical support. I mean, the user is kind of trying to discuss to a technical support. So and then if I run this, when will my order of Moto S50 will be delivered to me? It's a check order status intent. So the main essence of doing intent detection is to, based on these things, right? Based on this individual intents and individual strings, you can further decide the further plan of action. For example, if the intent is cancel order, next you can generate a system prompt or system query to the user that please give me with your order ID or give me with your product that you have ordered latest, right? uh, I mean, the path of execution becomes easier to decide once you detect the intent. So that's the main goal of intent detection. But if you can see here, it's not just enough to detect the intent here, right? If you see in the user query, there might be other useful information and metadata which you can extract from it basically, right? If you see, there is a product name called iPhone 16 here. Here, if you see that the product is mentioned is my Moto S50, I want to cancel, let's say, my latest order, right? So the latest is a very useful information and metadata for here, right? Because based on this latest keyword, we can identify the latest order ID from the database and show it to the user whether he wants to cancel that or not. So these are the some of the extra metadata useful information which we can actually extract from the user query, apart from along with the intent, right? But just using a plain prompt will make it very complex. I mean, you have to write a lot of things. Let's say you want to get the product information, right? Product name. I mean, the prompt will become bigger because you might have to write something like this. Okay, if there is product name, you might want to involve something like, if there is product name, include in the response. I mean, see, prompt can be designed like this, but it makes the output, less structured and very complex to manage. The output will be very complex to manage. So in order to tackle this problem, what we are going to do, we are going to use tagging feature of LangChain framework, right? We'll be using LangChain framework and its tagging feature to detect intent and extract different kind of metadata information. So now let's just jump to the next code file. Yeah, so this is where we'll be playing with the things here. Now let me just import some of the useful information, useful modules and keys. I've imported this, and if you can see, we are importing a few models here, right? Few modules here, right? Like chart from template, and from Pydantic we are using base model and field, and obviously we are importing the OpenAI model also, to which will be used as the LLM. Now let me just import this also, and if you see here, this is where we structure the type of output that it is going to provide for a given user query. So I've created a class called intent detection. So if you see, this class has three properties: intent, product name, and confidence, right? And along with each key and each field, I mentioned something here, right? I mean, there is some description about this field, like what it is trying to extract from the given user query. Now, if you see here, we are obviously mentioning the data type of the output. It will be string, product name will be string, and confidence will be float. Now, if you see the description, intent is nothing but the identified intent of the user query. Give others if you don't know the suitable enum for it, right? I mean, just like we fetched check order status, cancel order, this intent we fetched, this is what will be used to fetch the intent. Okay. Now next is the product name. That field description says name of the product if mentioned. I mean, this field should contain the name of the product if it is mentioned in the user query. If it is not mentioned in the user query, just send an empty string if the product name is not there. For example, let's say if someone asks query like this, ki, I want to cancel my latest order, or let's say just simple query like I want to cancel my order. We don't know which order he is trying to cancel or which product that is order he is trying to cancel. So in this case, we can generate an empty string for the product name key, so that if the product name is empty, we can again further ask the user key which product you want to cancel. Just let me just put it in the chat. So that's how we control the flow of execution. Then is the confidence, which is nothing but a the quality of the fields that has been generated, right? Intent, product name, how confident it is about the value that it has generated. I mean, it's optional. You can put it there in the intent detection model. It's up to you. But yeah, we are just incorporating here so that using this we can actually decide whether to re-evaluate the intent detection for a user query or not. If the confidence is very good, I mean, let's more than 90%, we are good to go with the data that information that it is extracted. Next, we are initializing the OpenAI model with our GPT-4o mini and a secret key I'm passing, and this is where the main things happen. With structured output, then we are passing the intent detection class. This class that I have created, I'm passing it in a method called with structured output. Basically, it will use this class, okay, to generate structured output for a given query, okay, for a given prompt. So let me just run this also, so that we'll initialize your LLM model. Then we are designing a prompt. So the prompt, just like we created prompt here, right? Here also we are designing a prompt, and we have written like extract the desired information from the following query. I mean, whatever the user is giving in the query, only extract the properties mentioned in the intent detection function. I mean, intent detection class that we have defined here. So for a given query, it will generate output using these three fields. Obviously, if you want, you can include more fields like this, right? Let's say you want to extract more metadata, maybe a lot of other information you might want to incorporate. Let's say order ID, right? You can involve the order ID also. If the query contains the order ID, it can extract that also. So based on your requirement, you can obviously increase this list of the field names. Then we are obviously putting the user query here. Now let's just run it for some of our use sample queries. If you see here, can you share specs of new iPhone 16? Let me just ask this question. First we are creating the prompt, right? Creating the prompt, then passing the prompt to the LLM. Okay, so this is our prompt. Using the query we have created the prompt, and then passing that prompt to our LLM, then printing the response. Let me just run this code. If you see, it has detected something like intent is product inquiry, product name is iPhone 16, confidence is 0.95. Now let me just run this. Can you set specs of, let's say, of new Moto Edge 45G 5G Fusion mobile, right? Which was launched last October. See how complex I made the query, but still it will be able to fetch the metadata from it. If you see, intent is about again product inquiry, right? Product name is Moto Edge 45 5G Fusion. Okay. Now if I ask this question, can you set specs of, I think it's repeated. Let me just remove this. Yeah. So the next query is my display is not working, how to fix it? If I run this query, see it went to others, okay, and product name is not mentioned, that's why product name came empty. Now similarly, if I ask the other question, let me just run for all of them. Yeah, if you see that it is appropriately generating the intent and product names here, right? Intent and product name, if it is there. So here it is order delivery inquiry, here it is cancel order, right? But if you notice one thing here, the intent that is detected, it is generating from its own, right? We don't have any control over this, but actually indeed we can control these things by using a list of enums here. Okay, now let's say in intent, what I'll mention, we can pass a parameter called enum. Okay, let's say this is the list. You can this will be a list of strings basically. Okay, so here we can include enums like this, key only provide the intent based on these enums. All right, cancel order, then comes our product inquiry, technical support, and obviously others, which we have already mentioned here, right? Give others if you don't find any suitable enum for it, or suitable intent for it. Okay, intent or enum. Okay, let me just write like this way. So you can pass this enum. So what it will do for this given field intent, it will only get the detect the intent as these strings, else others it won't generate from its own. So now just let me run this again. We'll initialize the LLM again, then prompt is already created. Now I'll run this query again. Okay, can you set the specs of new iPhone 16? Now see, the intent is product inquiry, product name is iPhone 16, and confidence is 0.9. So it has successfully detected intent from the given list. Okay, now let's just similarly run it for all the queries. Okay, I'll run for all of them. Then for this also I'll run. Yeah, Now if you see for all of them, we have can you set the specs of new Moto S45G 5G Fusion mobile. Intent is product inquiry. Again, product name is mentioned here. Similarly for this is the same question again, sorry. My display is not working, how to fix it? It's a technical support question because we have included that in the intent detection or enum class. Okay. So product name is, it is getting the product name as display, which is not correct actually. Further we can obviously fine tune it to handle this kind of edge cases also. Okay. Now if you see, I want to cancel my order. Product name is not mentioned, but intent is cancel order. So based on this cancel order intent, we can further ask the user to give the product name or the order ID which we want to cancel. I don't want my recent order to be delivered to me. Cancel order, product name, right? Obviously in this type of cases, you can add one more key called order ID. Okay. So order ID can be a particular order ID or some string like let's say latest, fast or last order, right? This kind of strings it can contain, and based on that we can decide the further flow. We will generate the queries accordingly to get the order detail and cancel it, right? So that's how things are done. And if you see this, when will my order of Moto S50 be delivered to me? So it's a check order status intent basically. Now basically we have the full control over the intent string that it is producing because we are defining these intents, and based on this we can code further steps like this, right? Based on the intent you can use those intents to plan and reason the steps and appropriately call the tools. So if you have not watched my video on the LLM agent, click on the eye icon above and you will be able to understand the LLM agents in detail. So I hope you understood how to efficiently extract metadata from user queries and generate extract information so that it can be further processed, right, in further steps. So as we saw, using just a plain prompting, things will work, but it will not be that much structured. So I'll recommend you to use frameworks like this and extract metadata from a user query. Okay. Now if you see here, see, this is the documentation which is there in the LangChain. So here they mentioned how to get things done like this. Whatever we discussed, similarly it is given things like here, sentiment, all those things. You can go through the documentation, you'll find a lot of things here. Okay. See, specifically for each field, we can define possible values for each property, description to make sure the model understands the property, required properties to be returned. So see here they use the enum. So description about a field is very much important to make the LLM understand about a particular field and accordingly extract the metadata information from the user query. Okay. So these things you have to take care of. Now there is one more thing called OpenAI metadata tagger. Okay. So you might land in multiple use cases where in the vector database that you will be storing will be using, right? Why do you use vector database? To store documents, right? To store documents in vector form in the vector database, so that later the semantic search can be applied on the vector search on the vector database. However, just along with the plain document, it will be quite useful if you just store metadata like this, just like we detected intents here, right? We detected some metadata, right? Intent, product name, confidence, all those things. If you just store these things also along with the document in the vector database, our semantic search output will be more accurate and better. Okay. So that's what it is saying. It can often be useful to tag ingested documents with structured metadata. This is what I'm talking about, structured metadata, just like what we saw here. Okay. Such as the title, tone or length of a document to allow for a more targeted similarity search later. Okay. But if you let's say have thousands or lakhs of documents, you cannot just write a script to individually generate metadata and store it in the vector database, right? So that's why this OpenAI gives a functionality to tag our document, not just a single document but a large number of documents it can tag using this OpenAI metadata tagger feature. Okay. What it does is basically how will it tag the documents? Because it will do so by using a schema that will be providing. Okay, it will just like we provided a schema here, right? It's nothing but a schema, right? The type of metadata that we want to extract. So similarly, we'll provide a schema. If you see, we will be providing a schema like this for my document, because you're developing you're developing application like IMDb. So in that case, for each user review, you want to extract some metadata from the user reviews. So we are defining a schema like this, right? So based on this schema, we'll use the create metadata tagger function from OpenAI, which what we'll do, see, we have created that metadata tagger function here. Then let's say we have n number of documents like this. Here for example, it has taken 2 documents, but let's say you have 1000 of documents. So what it will do, using the document transformer that we created above, okay, it will transform these documents. That means along with this page content, I mean this user review, it will extract information like this. And how it will show, how it will look, you see, enhanced, it is printed a document from the enhanced document, and the things will look like this. Okay, you see, this is the first document, right? Review of the B movie. Review of the B movie by Roger Ebert. This is the greatest movie ever. So by Roger Ebert, this is the greatest movie ever. 4 out of 5 stars. So this is one user review that was given, right, by user. From this, it was able to tag information like this, based on this schema, right? Based on this schema, it was able to tag things like this. Movie title is the B movie, critic is Roger Ebert, tone is positive, rating is 4. I mean, what is the tone of the review, whether it is positive, negative, those things it is able to extract. Similarly, for the second document, review of The Godfather by Anonymous. Review of The Godfather by Anonymous. The movie was super boring, 1 out of 4 stars. So this is a one complete user review. From this, it was able to tag this document with this metadata, right? As you can see here. So this metadata tagger, OpenAI metadata tagger, is used to store metadata, useful metadata for your large number of documents. And you can obviously store this metadata in your vector database along with this original document, right? Along with this original document, you can obviously store this metadata. So it will definitely improve your semantic search output, okay? When we'll be comparing things, when we'll be generating similar documents from the vector database, it will be quite useful for you, okay? So I'll recommend you to go through this documentation, okay? And how people are using metadata tagger, how they are doing intent detection, text classification, using the tagging feature of LangChain. So a lot of things can be done. Okay, it is quite powerful. I'll put this link of these 2 documents in the video description. Just check it out once. Okay, so yeah, that was about the intent detection process using LLM and LangChain. So I hope you understood whatever we discussed in this video, and you got to learn something new. If you found this video helpful, just put a thumbs up to this video and subscribe to my channel. Let's target to reach 2200 subscribers by the end of this month. So if you have got any questions about whatever we discussed in this video, put them in the comment section and I'll be sure to answer them. Thank you for watching this video, and I'll see you in the next one. Thank you.